Okay, so Leetcode practice time. So 2 goals in this video. The first one is to see how to solve this problem. And put in some solid code here and then test it. And the second one is to see how we are going to behave during the interview given the specific question. So let's get started. Random pick with weight. Okay, you're given an array of positive integers w. With w, describe the weight of the ith index. We need to call the function pickindex, which randomly returns an integer in the range 0 to w.length minus 1.pickindex, and should return the integer proportionally to its weight. Okay, suppose the weight is 1 and 3, the probability to return number at index 0 would be 0.25, and to pick this, the probability to pick the second number is going to be 75%. Okay. Yeah, I think it's pretty clear to me. So remember, always the first step during the interview is to try to understand the problem. If you have any question, please bring up the questions and have the interviewer to clarify them. And also think about the edge cases potentially that could happen. Let's see if there is any constraints here. Okay, so it already sets some pretty strong constraints. So w.length is between 1 to 10,000, which means we are not going to be given a empty weight array. And also pickindex will be called at most 10,000 times. Okay, so 10,000 times to be called, and with the length of the array to be maximum is 100,000. Okay, then we may need to think about how to implement pickindex in an efficient way. Sure. So the next step actually is to find the solution for this specific question. Find solution. So for this one, it is both we need to define some data structure, and at the same time we need to implement the constructor and also the API, which is pickindex. So first of all, we may need to decide how to what data structure to store that. So one way I can think about is we could define an array. So let's say the array of the weight. So the array of the sum from 0 to the current index. So let's say it is sum. So sum I would be the sum from of w0 all the way equal to plus wi. Okay, in this way we could, and when we do a binary search or even like a linear scan, so first of all we implement the pickindex, we use the random class provided in Java and pick a number between 0 to 1, and then it use a random number to times the sum of the w input array, and then do a binary search within the sum array. Then I think for each call for the pickup index, it's going to be log n regarding the runtime. If we do a binary search, I think that would be currently, from what I can see, it would be the most efficient way to solve this problem currently. So, okay, so let's see if there's anything else I'm currently missing. So, if it is equal to, okay, so the first index would be to the probability of that. Yeah, I think we should be good to go currently. So first of all, let's define the private attributes. So first of all, I would define a sum array, which is integer array sum. Let's say, how to say that? Let's say prefix sum array. And then we also need to define a integer which is a sum. So in this constructor, so what we are going to do is we are going to iterate through the so initialize the sum as 0 and iterate through the input weight array. So I is equal to 0, I is smaller than w.length plus I, and then sum plus equal to w I, and we put prefix sum I as sum. Okay, of course we need to new the prefix sum as equal to new integer w.length. Okay, so that is that, and okay, so now we are done with initializing it. So it is really the juicy part to implement the pick index. Okay, so I forgot that after we find the solution and communicate with the interviewer about how the solution works and the runtime analysis, space analysis, we need to the next step is to put some solid code there. So the code, in the coding part, we care about your speed and your correctness and the readability at the same time. So okay, so now we are going to implement the binary search algorithm. So we are going to have left as 0, right, we will put a so for the right we are going to put prefix sum.length -1, and we choose a random number. Let's say we choose a random number as random is new, I think it's new random or something like that. Let's see, in Java random, so Java random, okay, so Java random could give us a so it's going, okay, so random, new random, so what should we call the next between 0 to 1.0, so let's say the next double or next float I think is fine. So the next float, it is the next float, okay. And what we are going to do is so the random, so this one times the sum would be the number we are trying to look within the prefix sum, like which range it is falling into. So well, so left is smaller than right. If we are going to generate a middle. So middle is left plus right minus left divided by 2. Then we see okay, so if rand is larger than the made, if it is larger than the so if it is larger than prefix sum made, then what we need to do is, if it's larger than the made, if it is let's say if it is larger than the made, what the next thing we need to do is we need to move the left to the next element of made. Otherwise, what we need to do is we are going to set, it means rand is smaller or equal to the number and made, smaller or equal to, so we are going to put, let's say we are going to put made, set made as right. And finally we will need to return a left. Okay, so I think that's pretty much it about coding. So after we are done with coding, it's definitely the time we do the testing. So testing part, and first of all we are going to do some sanity check using some examples, explain at the same time we are going to explain how the code works. And then we are going to set up some test cases to increase the test coverage. So let's see, for this one, let's take this example, which is 131. So suppose the input is 1 and 3. So this is W, and the prefix sum would be equal to 1 and 4. And the sum is equal to 4. And suppose, okay, so take index. So first of all, we set left and right, left at 0, right as the last thing in the prefix sum. And then we call the random to generate a random float between 0 to 1 times the sum. So let's say we generate 2.5. So if we generate 2.5, we are definitely looking at, we basically need to return index as 1. So first of all, left is set as 0 and right is set as 1. And then made, so first of all, made is going to be 0 plus, okay, so made is 0 as well. And then we see that rand is equal to 2.5, which is larger than the made thing. Then we are going to move the left pointer by 1, set we are going to set left as made plus 1, so left is equal to 1 now, and left is equal to right at this moment. Then we return left. Now we are going to return 0. So let's see if the rand we generate is, let's say 0.1. So 0.1 times 4, which is 0.4. So at the very beginning, left is 0, right is 1, made is 0, and we see, okay, so this one, it is definitely smaller than 1. So we are going to put right as made. We are going to set right as 0, and after we break it, we have, and now it is going to break this while loop, and we return left as 0. So it seems to be good to me. Let's give it a shot by running. Okay, so it is accepted. Let's see if it is okay. So now we should be good about this question. So this one is binary search. It is mostly a binary search question, and the task case I would set up could be I would say it is more general. Let's say one edge case is if there is only one weight. Like the length of the weight is equal to 1, and also we set up, for example, we have weight array equals to 5 numbers, so something like that. Other than that, I think it should be good regarding the test coverage. So that's it for this coding question. If you like it, please give me a thumb up, and I'll see you next time.